Alright, this is the second video for Test 5, the Test 5 review. So on number 14, we're going to find the zeros for each function. Well, to do that, we set the function equal to 0. And this is a trinomial. It looks like we might be able to factor it using the AC method. This is a 1x squared, so I know I'm going to have an x and x here. And then I need two numbers that multiply to negative 48 that add to negative 2. 6 and 8 happen to work. Since it's a minus 2, I need the bigger number to be negative. So notice when we multiply, we do get negative 48. And when we add, negative 8, 6 and negative 8 is negative 2. So we set each of these equal to 0. And we get x equals negative 6, and here you get 8, and so those are our two zeros for this polynomial. In other words, if you plug these numbers into the function, it will equal 0. Alright, so on part B here, we have 2x squared plus 10 equals 0. Notice there's no x term, so I would use the square root method. Quadratic formula would work, but there's really no reason to use that. You could actually use factoring as well, but square root method is probably going to be the best. We'll subtract 10 on both sides. Again, I want to get x squared by itself. 2 is not a perfect square. If I took the square root of 2x, I would not get 2x. So I don't want to do that. I want to get rid of the 2. So let's divide each side by 2. We get x squared is equal to negative 5. We'll take the square root of both sides. Now remember, when we do that, we got to do this plus or minus thing. There's going to be a positive and negative answer. We get plus or minus square root of 5 times I. Remember, all we can do is pull out an I here. If you want, you could always do this. Square root of negative 5 equals square root of 5 times square root of negative 1. That's square root of 5 times I. I like to just pull out an I. Change the sign. Alright, so that's part B. On part C, let's go ahead and set 3x squared plus 4x minus 1 equal to 0. We need two numbers, if we try to factor this, that multiply to negative 3 and add to 4. We can't get that because notice these numbers have to have opposite signs, and they also need to add to positive 4. There's no way to make that happen. So we're going to have to use quadratic formula. We have A is 3, B is 4, and C is negative 1. Oh, I must be getting tired here. This is minus b plus or minus square root b squared minus 4ac all over 2a. So let's plug in our numbers. We get negative 4 plus or minus square root of 4 squared minus 4 times 3 times negative 1 all over 2 times 3. So negative 4 plus or minus, notice here we're going to have 16 minus, we're squaring the 4 and we're going to subtract, it's 12 times negative 1, so minus negative 12. That's going to be the square root of 28 all over 6. Now the square root of 28 is the square root of 4 times the square root of 7. Notice 4 is a perfect square factor. So it simplifies to 2 square roots of 7. So we're going to get negative 4 over 6 plus or minus 2 square roots of 7 over 6. So finally, we end up with 2/3, negative 2/3, plus or minus the square root of 7 over 3. Because this would be 1/3. If you want, you could put a 1 here. And so that's going to be it for number 14. Our two zeros are negative 2/3 plus the square root of 7/3 and negative 2/3 minus the square root of 7/3. Okay, look at number 15. This is what we call quadratic in form. If this were an x squared and this were an x, we would just use the AC method, and we're going to do the same here, except instead of x and x, it's going to be x squared and x squared. Otherwise, it's the same. We're looking for two numbers that multiply to -3 that add to 2. 1 and 3 are the only factors of 3. And I need a positive 2, so let's make the bigger one the bigger one positive. 3 times -1 is -3, and 3 plus -1 gives me the 2. I have two things here that multiply to give you 0. So one of them must be 0. Either x squared minus 1 is 0, or x squared plus 3 is 0. We're going to have to use the square root method twice. We get x squared equals 1. We'll take the square root of both sides. That's x equals plus or minus 1. Over here, we're going to get x squared equals -3. We'll take the square root of both sides. We'll get x equals plus or minus square root of 3 times I. So those are our 4 solutions. Notice this was a 4th degree equation, and so that's not a surprise. All right, let's move on to number 16. All right, so it says find all the characteristics listed below for the quadratic function f of x equals 2 times the quantity x plus 1 squared minus 4, and use them to graph the function. Now this is in vertex form, so it's a times x minus h squared plus k. We know the vertex is hk. Well, in this case, h is -1 and k is -4. Remember, use the opposite sign of what's here. That's because the formula has a minus in it. You could think of this as x minus -1, so h is -1, and then k is -4. So our axis of symmetry is x equals -1. It's always going to be x equals that number, the x value of the vertex. Notice it asks, how is this graph different from the parent function y equals x squared, which we know is just a parabola that's at the origin? Well, there's no reflection because there's no minus out front or inside with the x. So there's no or none, no reflections. Stretches or shrinks. The 2 will cause a vertical stretch. Could say by a factor of 2. So basically each of our y values are twice as big as they normally would be. The shape looks more narrow than a regular parabola. And then shifts. Notice we've got a shift 1 to the left and down 4. So 1 left and down 4. Could say it's a horizontal shift left 1, vertical shift down 4 if you want to be real specific, but this should be good enough. So now we're ready to graph this. So we want to plot our point, our vertex, -1, -4. By the way, we know this opens up because a is positive, so our graph's going to look something like this. So we need to find a couple of points. I didn't ask you to find the y-intercept, but that would be a good idea. Let's find f of 0. Oh, by the way, we should put in the axis of symmetry here. So we know it's going to look something like this. F of 0 is 2 times 0 plus 1 squared minus 4. Well, 0 plus 1 is 1, and 1 squared is 1. So we're going to get 2 minus 4, or negative 2. So 0, negative 2. So we know if there's a point here on the right side of the asymptote, there'll be one on the other side, same distance away. So we're getting this point using symmetry, and that should be plenty to draw a decent graph. What's our domain? All real numbers. There is no left or rightmost point. What's our range? We do have a lowest point. Remember, we want to go from the lowest to the highest point. So our y value at the lowest point is negative 4. And there is no highest point, so it goes negative 4 to infinity. All right, let's move on to the last page. So on number 17, this is not in the vertex form. This is what we call the standard form. And again, the vertex is the most important point. To find it, we use the vertex formula. X equals negative b over 2a. In this problem, a is negative 1 and b is 6. And so this is negative 6 over 2 times negative 1. That's negative 6 over negative 2, which is 3. So the vertex formula gives you the x value of the vertex. To find the y value, we want to plug 3 into the function, the corresponding y value. So it would be negative 3 squared plus 6 times 3 minus 5. Now be careful here. There's no parentheses around the negative x here. We're squaring just 3, which 3 squared is 9, and then applying the negative, you get negative 9 plus 18 minus 5. Negative 9 plus 18 is 9. 9 minus 5 is 4. So the point 3, 4 is our vertex. Our axis of symmetry will be x equals 3. It says find any x or y intercepts. Well, f of 0, it's actually pretty easy in this situation. It's going to be 0 comma whatever this number is, because when you plug in 0 here, here, and here, you're going to end up with f of 0 equals negative 5. So 0, negative 5 is your y-intercept. 0, negative 5. And by the way, we know this is going to open down because of the negative out front. So we already knew what the graph is going to look like. Now we have a point. We can use symmetry to get another point. Now notice they do want us to find the x-intercepts. So we'll set minus x squared plus 6x minus 5 equal to 0. Now this is not really ideal. We don't want a minus on our x squared term, but there's an easy way to deal with this. Just multiply both sides by negative 1. When you multiply this side by negative 1, you're going to get 0. And when you multiply this side by negative 1, you'll distribute the negative 1 to each of the terms. So you'll get x squared minus 6x plus 5. So let's try to factor that. It's going to be x and x. 5 times 1 is the only way to get 5. They're both positive or both negative. Since they add up to a negative 6, they must both be negative. Notice that's going to work. We get x is 5 and x is 1. So when we chose y to be 0, f of x is just another name for y, we got 2 points. 5, 0, and 1, 0. And that's what we were expecting, that we'd go through this x-axis twice. So what's that? 1, 0 and 5, 0. And you'll notice the symmetry here. We're 2 away from the axis of symmetry on each side. So that's what we would expect. All right. So what's our domain? Our real numbers. The range. Now going from the lowest to the highest point, there is no lowest point, and there is a highest point, and the y value there is 4. So negative infinity to 4. The minimum or maximum for this function, well, we have the highest point here, we're going to have a maximum there. And this value, the maximum value is 4, and it occurs when x equals 3. So basically what that means is no matter what you plug into this function, the largest output you'll ever get is 4. You can see all the outputs, they're the points on this graph, the y values. All right, last problem, number 18. It says if an archer shoots an arrow straight upward with an initial velocity of 160 feet per second from a height of 8 feet, then its height above the ground in feet at time t in seconds is given by this function here. Now the thing you learn about these numbers, the velocity, so initial velocity, that means when it was first shot, that's the speed it was going, and it was 8 feet high when it was shot up above the ground. All of that's built into the function here. So you don't have to worry about that. You just have to worry about 2 things. H of t is the height of this arrow, and t is the time in seconds. So this function gives us the height of the arrow after time t. All right, so it says, at what time does the arrow reach its maximum height? Well, notice this is a parabola that opens down because of the minus out front, which would tell us we are going to have a maximum. So where do we find that? It's at the vertex. We need the vertex formula, x equals negative b over 2a. Now keep in mind our input here is actually not x, it's t. So I don't really care, you can use x or t. In this case, b is 160, so we'll have negative 160 over 2 times a, which is negative 16. You'll get negative 160 over negative 32. And let's see, what is that? That is 5. So at what time does the arrow reach its maximum height? That's what we actually just found. After 5 seconds. What is the maximum height? Well, remember, the maximum value is the y value of the vertex. So far we found t, and now we need to plug that into the function to get the actual height. So h of 5 is negative 16 times 5 squared plus 160 times 5 plus 8. And you should get 64. So the maximum height of the arrow is 64 feet, which basically means 64 feet above the ground. All right, and that is the end of the review for test 5.